If I start and you don't see the little recording thing going on, feel free to shout that out to make sure that I do record. It's just in case one of you, internet crashes or something, then you'll have something to come back to look at. That's kind of the main idea. All right, with that, let me jump over to where here. Why does it not want to? One second here. Now that I'm back on on Zoom after a while. There, show all the windows. That's it. So you should be able to see my screen, and let's do that at full presentation. There we go. All right. So today we're gonna talk about our project in a little more detail. And so the hope is that you guys can get started on this very soon. I'm gonna not take up the entire class time today, probably, with this. So for the remaining part, I would really like you guys to reach out to the rest of your project teams and start figuring out where you want to go with your project, right? Because after today, I hope you'll at least have an idea of what it is that we're trying to do. So let's get right into this. Oh, by the way, before we get started, completely off topic. I was sitting outside eating my lunch earlier today, and there was a bird walking along the balcony, and it had the most pronounced this kind of movement that I've ever seen in a bird. Does anybody know why birds do that? Like do the weird moving the head back and forth? I first thought maybe it's something about keeping their head stable in the same position, but just seeing it from the side, it was doing this as the bird was moving. So I was just wondering, okay, that's kind of one of those little observations that happen as you go by. Because I have no idea why they do that, but it seems to be very common for birds, so it must be a reason. No bird specialist here. I'll look it up. Maybe I can figure it out and talk about it next time around. All right, but we kind of talked about this idea when we talk about bio-inspired design, that we have two approaches, right? We have the approach that we call the one that was problem-based and the one that was solution-based, right? And so that's the same thing here, just it's a little more like some different words, right? So there's the biology to application approach, basically is the solution-driven approach, right? So in this case, we've seen that the geckos have this amazing ability to stick to walls, and so how can we use that for something that we want to do, right? So that I guess the most direct problem that we could have there would be climbing up a glass wall or something, right, for maintenance or something. And so we could do that directly, for instance. So that would be the part, again, where we see something in nature, we think this is really cool. How could I possibly use this for technology, right? And the other one was the problem based approach, where we see in technology or in society that there's a specific problem, and then we look to nature to see if there's a way that nature does something similar that would help us, right? So in this case, we have some American football players, and they're banging their heads together, which obviously is not a good thing for your head, right? Our heads aren't necessarily designed to bang into each other all the time. And that's why a lot of these football players get repeated concussions, and some of them have like long-term brain impairment due to that. And so the question is, the first question is, why are we doing this? Can't we find a sport that's a little less damaging to our brain? But I guess people like what they like. But the other question then is, how can we prevent that? How can we make that less dangerous? And of course, people have built bigger and better helmets and all that kind of stuff. But at some point, and we'll talk about this example again, so let's do it briefly. But at some point, people thought it's like, well, if you look at this little woodpecker here, that woodpecker bangs its head against the tree over and over all day long. Not all day long, but like multiple times a day, right? They don't get brain damage. Why? What happens? Why don't they get brain damage? And well, the first thing you have to know about this type of brain damage is that the reason it happens is that our brain doesn't actually fill out our skull completely, right? There's a little space in between our skull and our brain, and that's filled with liquid. But if my head jerks to one side or another hard enough, then my brain actually bangs against my skull. And of course, the same thing would happen within a woodpecker. But what woodpeckers have, they have little muscles that sit on the arteries that go in and out of their brain. And so just as they're starting to start hitting the tree, those muscles contract just a little bit. And so there's less blood flowing out of the brain. So the brain swells up a little bit, right? Because there's more blood going in than there's blood going out, which means that it actually, for that short amount of time, it fills that cavity completely. So if I move it around, there's no way for it to slosh against anything. So there's no brain damage. And so people have actually developed collars that you can put around somebody's neck that have a little button, basically a little pin here that pushes against those arteries and does the same thing. And it's turned out to be very, very effective, right? But of course, also heavy and costs money, right? So it's not being deployed that much yet. But that would be the idea where I saw a problem and then trying to find a solution. And for our project, we will be doing that, right? We will be looking at, or you will define a problem that you want to solve, and then you will go through and use the solution from biology, right? So instead of going the bio to, like, the solution-based approach, we'll do a problem-based approach. And the reason for that is that we tend to run into problems all over the place, right? So it's easy for us to find problems, and you can see a whole bunch of them here, right? Obviously, this construction here didn't go so well. Is there something on this picture that screams out right away that this is not an actual picture of a bridge?
Two columns.
Exactly. Two bridge piers are right next to each other, right? Who would ever do that? You would never do that, right? And of course, if you're doing this construction, you would see that your bridges aren't, like, your bridge halves aren't lined up long before you get to that point, right? So you'd be able to adjust, and you shouldn't even get to that point. Now, the cool thing is I actually was on a bridge that was a little more constructed than this. So there was maybe half a meter, quarter of a meter distance between the two ends of a bridge. And this was a very slender hanging bridge. And so neither of those 2 points was actually sitting directly on a bridge pier, but they were like farther back. And so we were there as students with the construction manager of the site, and he was so excited about this bridge. So he had a couple construction people come out, and they basically took big poles and pushed counter to kind of the gap. And it was like maybe three construction people, and they were strong and everything, but they were able to push that bridge side to side by, I say, maybe half a meter or something, like, without any problem. That's how soft and flexible these bridges are, which of course they have to be, right? Because there's all kinds of motion happening. We don't want to have them rigid, then they'll break, right? But that would be a problem. Obviously, having water coming out of your electricity sockets is not great, especially if it's water. Water and electricity don't fit together very well. This building here just basically fell over. So this would be something where, for those of you who are also in the seminar, right, this would be something that the foundations didn't work out very well. So wherever the geotechnic people are, did not do a sufficient job. The cool thing is, if you look at this picture from this river here, there's a whole bunch more of these buildings. I mean, they're all standing, but it looks almost like dominoes. So if they had been a little closer, then we might actually have had like real life building size dominoes. That would have been interesting, at least from a distance. Here we can see somebody building a concrete block onto the railway. Obviously not very good. Now, the good thing is that it doesn't look like this railway is being used all that much, because there's a fair amount of rust on the top of these, right? If this is being used, then these should be nice and clean. So this is at least like a couple days or something. And it looks, if you look carefully, it looks like there's some kind of a cover that's sitting on these railroad ties here. So maybe this is just supposed to be something that's temporary, right? Maybe there's a construction that's going on and they just need to put this in because they needed to have a foundation for this, equipment here. And then 2 weeks from now, they're going to take it away and they put the cover on there to make it easy to remove. Now, we all know the Leaning Tower of Pisa, right? Which is obviously a very, very interesting piece of a problem, because again, it's a foundation problem, right? So they started building the tower, and as they were building it, they noticed that it was leaning. So you can actually in this picture see how they're trying to course correct as they're going up, right? So this tower is actually not a straight tower, it's kind of goes like that because that's how fast this was. And then what's the problem on our last little picture here?
It's a pretty obvious one.
I would say so, yes. And it is.
The stairs.
Exactly, right? So you have this ramp here for maybe for wheelchairs or for baby buggies or whatever, but the ends again in stairs, right? So it's completely useless. Right. So these are obviously problems that are, I would say, very small in scope, right? But I will want you to find something that's a little more bigger, like a little bigger, right? Something that like a societal problem that you think you want to fix as a team. Right. And so kind of the steps that you're going to go through is you'll identify what the challenge is, challenge, problem, whatever you want to call it. Then you will discover the biological models, and then you will develop your own bio-inspired design. Now, this design does not have to be that you hand me over a bunch of blueprints that we're ready to construct and sell or something, right? But it has to be well thought out. It has to have sketches. If you want to do drawings, if you want to do like any other kind of thing, right? That's what I would like to see. Now, maybe just some quick examples here that we can go through. One problem that, of course, everybody knows about, because I think we've all been to the doctor once or twice, is the pain of getting injected with a needle. And if you think that's not so painful, that's totally fine. Make sure you take whenever you have kids or your nieces or nephews or whatever that are in the toddler stage, and take them to the doctor and have them be injected with needles. It's big fun, I can tell you, with my kids, right? Or used to be, now they're fine. Right, but so we want to develop needles that don't hurt as much as they go in. And so the idea then would be, if that's the problem that you want to solve, right? Please don't choose it because we're talking about it now, of course. Would be to look into nature and see, like, well, where does nature kind of try to trick you, try to put something into your skin or something, right? So we could say, well, there's thorns on a rose, right? Those certainly work. There's looks to be a cat's paw, right? They have little claws on there. Then we have all kinds of other animals. And why can't I think of the name right now? It's not a hedgehog. It's the thing that I'm thinking about.
Porcupine?
Porcupine, thank you. Thank you very much. You've ever seen a porcupine quill or interacted with one? Hopefully not. Anybody? They're fairly long, like kind of hollow, almost looks like a straw kind of a thing, but quite sturdy. So that'd be a porcupine, and then of course the national bird of Costa Rica, the mosquito, right? Now, if my goal is to develop a needle that is less painful going in, right, to inject something, then which do you think would be a good model of these four to look into more detail?
You would use the mosquito model.
Why would you use the mosquito model?
Because when you get bitten by a mosquito, you don't feel it until later when you start scratching your arm.
Exactly, right? So the mosquito has developed a nice little injector that is designed in a way, and we'll talk about this once we talk about biomedical stuff. It's designed in a way to sting you without you noticing it, right? Because obviously the mosquito doesn't want to be slapped while it's sitting on your skin, because it's very exposed, right? So it can't move as long as its stinger is in your skin. And of course, most of these other ones would be horrible examples, right? If you think about a cat's paw and the porcupine needles, right? They're designed to stay in your skin. They don't want to come out, right? That's kind of and roses don't stick in there, but they're very broad. So like it's actually quite difficult to get them all the way into your skin, right? So those would be good examples. All right, so that was one example. Here's another example, right? So we have a package that we want to receive, and we want to not have it look like this, right? This is obviously is not ideal. And I wish I had taken pictures, but I didn't. But when we first moved to Costa Rica, we used this little moving company just for a couple of boxes. They were like big cardboard moving boxes. And when they delivered them, I almost had a heart attack because they looked basically like that box right there, and they were wet and they were torn, and it was like there were computers in there and all that kind of stuff. Fortunately, there was only one dish that broke, but so we want to have packages that are impact resistant. And so we'd go again, right? We'd look into nature. What things can we find in nature that are impact resistant? Well, we can think about these mountain sheep, right, that bang their head together, these males. And so these horns that they have must be extremely strong, right? Because there's going to be very strong impacts. We already talked about our own skull, right? That's something that's nice and rigid, keeps our brain safe most of the time. We have eggs, right? They are relatively strong. Of course, you can crack them, but for the amount of material they have, they're very good. And then another way we can think about impact resistance is something like a kangaroo, right? So a kangaroo bounces up and down, doesn't break its legs when it lands, right? It's able to kind of balance itself out, right? So what would you think in this case might be a good model? This case is not obvious, right? The other one was very obvious, but I think this one there's a little more.
The mountain goats?
The mountain goats? Okay, why would you think the mountain goats are a good model here?
Because the horns are made to, from what I'm seeing, they hit themselves with them. So they are probably designed to make the impact softer on the biological tissue that's below it.
That sounds like a good reason, right? Because in the end, our whatever's in the package is kind of what in this case, like, you know, the brains or something else underneath the skulls of the mountain sheep would be. Anybody else? Right, you could say the skull kind of similar, right? I mean, it does kind of a similar function there. It's not as strong. Eggs, I mean, eggs would be interesting to look at from the standpoint that there's not a whole lot of material, right? That creates a fairly strong system, but of course they're not really. They're good for high forces, but not so much for an impact, right? It's easy if you want to break an egg. You don't kind of hold it in your hand and squish it, right? You just kind of smack it against the corner or something, and then it breaks open easy, right? So maybe eggs aren't the best. And then kangaroos, yeah, I think that'd be way too much kind of mechanics around a package to keep it safe, right? So maybe the horns and the skull might be the best way to go here. And of course, if you really want to do this, right, you could look out, and there'd probably be a whole bunch of other ways to do that as well. And then maybe something, you know, completely different here to think about, and that is, how do we store water, right? So here we have, think about water storage, right? We can say like, well, how do plants in the rainforest store water? Obviously, they don't have to store it for very long because they know it's gonna rain again. But if you think about most of Costa Rica, right? I mean, it does rain a lot during the rainy season, but not so much during the dry season. So what do these kind of forests do during the dry season? What happens if your vegetation that lives in an environment where it doesn't rain all that much at all, right? So we have kind of a shrubland here with big cacti and little shrubs all around. And then on a whole different thought about it, like, how do you store water in an environment that is filled with water, right? So in this case, it would be, how do you, for instance, fish store fresh water inside them instead of while they're swimming around in salt water? Right. So here I think this is kind of water storage is a very broad topic, right? So any of these could be good models. And so I think what I want to say with this one is that you have to be sure that you narrow down the problem that you're trying to solve in a sufficient way that you can actually do something about it, right? If you just say, I want to have better water storage, then there's so many follow-up questions that I can ask, right? Like, what's the storage for how long, how much, all that kind of stuff, right? And so you want to be a little more directed with this. And always remember that you can go back to asknature.org and that can help you find these natural models, right? These biological models. That doesn't mean that if it's not there, you can't think of it, but that might be a good starting point. All right, questions so far? Please remember that it doesn't matter if we're online or in class, right? If you have questions, just let me know. And please don't put questions just in the chat or something, because I'm not looking at the chat while I'm teaching, right? I'll see it afterwards. But if you have a question right away, just straight up and ask it, and we'll get to it. All right, now your project will have 3 main parts, and then there's kind of a little extra part at the end. There's the first big one is what you're going to start working on, hopefully, or thinking about at least today, is the proposal, where you basically say, what is it that we're trying to solve, and maybe a little background information on that. And then there's what we call the annotated bibliography, where you've already now decided what the problem is, and this would be you going out and trying to find biological models. Like, what is it that we can do, and basically give me a list of papers that you think are going to be related to it, like articles, but scientific articles, not newspaper articles. And then, of course, I want to see a final design. How are you going to solve the problem? And again, it doesn't mean you have to hand me over a physical design or something, but you have to think about how it's going to work and give me some level of detail. And then the last part on here, which is kind of part of the final design, is that at the very end of the semester, I want each of you to write me a project report. So for the big final design, you don't have to write a report as a team. You'll get a presentation instead. But as individuals, I want everybody to write down about the project, and you'll get details of that as we get closer. And the reason for that is just I need to have something on the individual level that I can grade, right? Just because, as you will all find out and probably already know, right, if you're working within a team in a project, then sometimes some people don't do all the work and they still get the same grade. All right, let's talk a little bit more about our proposal. All right, so basically it will describe what you will investigate, why it's important, and potentially how you'll do the research. Although it's a little bit more part of the annotated bibliography, right? So you'll start with an introduction, which kind of sets the overall groundwork. Then you will give the problem definition, the objectives, and the impact. And we're going to go through each of those in a little more detail. So the introduction introduces a topic, as the name says. We'll give some background and some context, right? So how is this problem important to other people? And it kind of ends with your problem statement, right? So this is exactly what it is that you're trying to solve. Then the problem, right? So you'll identify the overall problem area. Then you'll learn about detail about the problem, like who is being affected by this problem. Are there any other solutions that are already out there? Maybe is there some current thoughts going around about new solutions, or if it's important or not, that kind of thing. And to do this, to kind of talk about the problem, it's a good idea to think about this in this kind of problem tree idea, right? So basically, this thinking about a problem like a tree means that you think about the problem itself would be kind of the trunk, where everything comes together. The roots are all the different causes that this problem might have. There's going to be different layers of different levels of causes. And then the branches are going to be the effects that the problem has on society or the environment or whatever it is that we're interested in. All right, so here, the way that we can think about this is if we put it in this chart here, right? So again, the trunk would be the core problem, and then there's all these different effects, primary, secondary, they can be tertiary, right? There could be all kinds of levels of effects, and of course, the problem is all based on all these causes. All these causes create the problem, and then the problem affects the environment or society. And so here is an example maybe to kind of illustrate that, right? So in this case, the problem would be that the river water quality is deteriorating, right? So deteriorating means it's getting worse and worse and worse and worse. And then, well, if we want to solve this, right, if we want to think about this river water, if we do think this is a problem that needs attention, right, then the only way for us to solve it is to figure out what the causes are, right? If I don't know what causes the river water to go bad, there's no way for me to fix it, right, to make it any better. So we have three main causes, right? We have high levels of solid waste dumped into the river, right? It means kind of like up in Escazú, right? People are just throwing their garbage straight into the little stream, right? All right, that's obviously not going to help with the water quality. Another core problem is that most households and factories discharge wastewater directly into the river. Factories maybe not so much, but households up along those little streams in Escazú, that certainly is also the case, right? And then another big problem is that wastewater treatment treated in plants does not meet environmental standards, right? So in this case, for our little streams up in Escazú, that would be basically the way that people treat their wastewater before it gets to the stream is not sufficient, right? So these would be the main problems, the main causes that we think make the river water bad. But of course, these causes have other causes, right? So for instance, if we stick with the center one here, so we don't go right through everything, right? But if you can say this was that the households just dump their wastewater into the river, right? So why do they just dump it in there, right? Well, it means that the reason why they do it is because there's just not enough regulation to prevent them from doing that, right? If that's the easiest way to get rid of it and nobody says you shouldn't, then you know, why aren't you doing it? And another reason why that's a problem is because not very many households are connected to a central sewage system, right? So think about up there in Escazú, there's no centralized sewage system, right? So these would be secondary causes. And so now if we want to go even a step further back, right, we can say like, why isn't there existing legal regulations? Well, it's because pollution has not been a high political priority, right? So nobody in politics cares, so they're not coming up with new regulations to make pollution more difficult, or like, you know, to go harder against it, which means people are dumping more stuff in the river, which means the water is going bad, right? So if I have this chain of causes, then I can think about, well, where in this chain of causes do I want to do something? How do I change something, right? Well, clearly I want to change the number of households that are dumping wastewater into the river. But then I have to think, how do I want to do this, right? And so in this case, for this string right here, the only way to do that would be to make sure that pollution has a higher priority so that new regulations are made that then can be promulgated and like, you know, put into place and stop the people dumping stuff, right? We think about this side, right? Then I could say like, well, if only 40% are currently connected to a central sewage network, then maybe what we have to do is build more sewage networks, right? Of course, which means there's costs involved and all that kind of stuff, right? So, but that be kind of the approach to think about what my possible solutions could be. And there's, of course, other solutions that I could think of as for the other big problems as well, right? But the idea, again, is to look at what the causes are and then see what happens. Now, on the upper side, we want to see what the effects are, right? So maybe I walk down along my stream and it like looks a little cloudy or it smells a little bad, right? I'd say, ooh, this, like, you know, the water quality of the stream is really poor. We have to do something about this, right? But then I look at the effects and I see, well, you know, the fish are all still doing fine, and you know, the people who live next to it don't seem to mind the smell. maybe it's not something we have to deal with, right? So maybe the effects that this problem has on the environment or society is maybe not so bad. Now, if I have a stream that has bad water quality, right, then, well, my whole ecosystem of that river is going to be under serious threat, right? So it could cause all kinds of problems. For instance, reducing the amount of fish that I can get out of this river, right? And if there's no more fish that I can get, then people maybe don't have enough to eat, and they become sick because they don't have food. Dirty water also often carries all kinds of diseases, right? Especially if it's fresh sewage. So that could also impact people and cause health problems, right? So in this case, I can find that there's probably a pretty strong impact that I want to have from this river water. Any questions about the figure that we have on here, kind of the idea of how to go through these steps? No, everything relatively clear, right? So this is, as you're working on trying to define your problem, this is a good way to think about it, right? And maybe a good idea to add something like this to your proposal, right? Now the objectives, right? So that was kind of the first thing, was the problem statement. Now the objectives, right? That's kind of what it is that you're trying to do, right? These are kind of the aims of the study that you kind of do, or that why you're trying to solve this problem. And in a way, we could think about, take the same figure here, and we can just, instead of saying that it's causes, problems, and effects, we can also call this means, objectives, and ends, right? So basically the objectives are going to be sitting here. What are my objectives, right? So in this case, the objective would be to improve the water quality of the river, right? The means are basically the lowest level of things down here, or all these, I guess, to some degree, right? So the means, and if we stick with our specific example, right, the means of improving the water quality would be to reduce the number of houses that are discharging into the river, right? So that be the same thing, right? And so, and then the ends, right? So this would be all basically turning the things that were kind of negatives on the previous slide, or the two previous slides, into positives, right? So here it's now that the threat to the river system is reduced and the fish stock is increased, right? Because we've cleaned up the river. So this is kind of what you would hope to come out in the end of your project. Now, impacts was another big thing that needs to go into the proposal, and that is basically, it's to show what the potential implications are of the way that you want to solve your problem, right? And so obviously that one of the impacts should be that it's improving what it is that you're trying to solve, right? So if my goal is to clean up the river water, and I find that my process is producing all kinds of other pollution that's going back into the river and is contaminating the river again, then that's maybe not really solving the problem. And then there's you can think about how what you're doing is impacting policies. Maybe some of the things that you're trying to do are going to be challenging popular or scientific assumptions, right? That's always a tricky place to be. Remember, we talked about this when we talked about the Bennius chapter, right? The idea of what happened when we kind of started thinking about the Earth being rotating around or orbiting the sun instead of everything orbiting Earth, right? How that kind of change of popular, in this case, and scientific assumption, that we were the center, how that changed, right? And how that was a challenging thing. So that would be kind of the impacts. And so that's basically what your proposal is going to be. Now, you're going to talk to me about your proposal before you come up with it. We're going to kind of, again, today work on it for quite a while, because we're basically done with the slides. And I want to kind of start thinking about what it is that you need to do. So it's going to be due on Thursday the 28th, which is 3.5 weeks from now. You're about right there, right? So you do have some time to work on it, but don't wait for 3 weeks and then start working on it, right? So let me go through kind of some some details on it, and then I'll tell you what I'd like you to do next. And so this proposal should be up to 4 pages long. This does not count like references or figures if you stick them in. You really have to have references. There's no question around it. Any figure that you show should be referenced in the text. So don't just add pictures for them to look nice, right? I know that's something that kind of in high school people do quite a bit, right? If you do a little report or something, you put in a couple pictures just to make the whole report look a little nicer. In our case, we don't want to do that, right? So we are engineers. Everything that you put into a report has to be there for a reason, right? So if you have a figure there, then in the text somewhere it has to say, as can be seen in figure 2, you know, the arms of this plant are longer than the other, or something like that, right? But there has to be a clear reference to it. You need to cite any work or ideas of others, and be very clear about it. You need to do your citation not based on your own personal preference, but based on a common standard, right? That could be APA or whatever else you want to use, but it has to be a standard. You should not cite web pages just because they're not permanent, right? That's always the difficulty. I know there's the thing about referenced or like, you know, visited or something at this specific date, but overall it's not good to reference web pages. And the reason why that is basically is that whoever reads this proposal, right, should be able to follow up on anything that you cited there, right? If you say like, as John Smith said, like, you know, cows are green and fly, right? Then, and you have a citation there to a website, and the person goes there, well, that website is down, they can no longer verify what you're saying is true or not, right? So your proposal should be something that's not only usable the minute you're creating it, but like, you know, it should be in perpetuity, right? It should be there for a long time, for potentially forever, right? So you should not reference web pages. Where possible, you should cite scientific articles, right? So a scientific article is something that gets published in a journal. This is not something that's like, you know, a regular newspaper or a regular website. We'll talk about this more, obviously, before you do your annotated bibliography. We'll talk about this a little bit in the seminar as well. But it's really important for the proposal, not quite so much, but for the annotated bibliography, it really has to be scientific articles, right? Because we want to make sure we have good data. For the proposal, you should have at least 2 citations. You need to proofread for grammar and for typos, right? So if there's a whole bunch of typos or sentences that go over a full paragraph, or like, you know, grammar, like word choice that's mixed around and all those kind of things, right? Then that will cost you some points. So make sure that you do that. If you're uncertain about your writing, remember that there's the writing center that you can reach out to. They can help you restructure what you're writing. They're not going to go through and look for your typos. That's really up to you. I think by now everybody's going to be using some word processing software anyway, and they should tell you what your typos are relatively easy. You have to be a little bit careful with false friends between English and Spanish. There's some words that pop up every now and then. My favorite one is a doubt. So in English, a doubt is really something more very like, wow, I'm not so sure what that person is doing correct. But in Spanish, it's used much more as a question, right? So you have to be a little careful. I get a lot of times when I read first-year students' work, there's like, well, I have a doubt about this or a doubt about that, when they're really saying I have a question about this or that, right? So those kind of things, try to keep those in mind. We are no longer in high school, so please make sure that you use a professional font, right? Something like Times New Roman, Arial, whatever the one is that Microsoft tries you to use. Any of those is fine, but it has to be something that's professional, right? And use a font size of 12 for the main text. Now, I used to
Microsoft really likes Calibri for a reason. I don't know why.
Right. Well, the reason they like Calibri, and I always kind of stepped away from it, but I have now learned that Calibri is actually was partially designed with the idea of being easily readable for people who have visual impairments. And so if you're using like a device that is trying to read something and translate it into text for you, Calibri seems to be like just the way that the font is set up seems to be very well suited for that. And that is the reason I think why they pushed it. And that's the reason why the New York Times, grand old newspaper that came up with the font called Times New Roman, because that's what their name is, they are now switching away from Times New Roman because they have found that it's just more difficult for people with visual impairments to use. So that's why it's there. All right, what I wanted to say also is, so I say here the font size is 12. The question that I usually get is at some point or another is like, well, like, what's the pay, what are the margins, like, double spaced, single spaced? That's entirely up to you. I do want to highlight, well, I should highlight it here, but like professional is kind of the big one there, right? Don't give me something that has about this much text in the middle of the page, double spaced, right? Because there's nothing on there. The other thing that you will notice, usually quite quickly, is that if I tell you to up to 4 pages, you're going to struggle not going beyond the 4 pages rather than having fewer than 4 pages, right? That's usually you have enough to say to be able to fill that space easily, and it's more a question of how do I get more text onto my page instead of less. If you don't have a whole lot of things to say, then maybe think about that a little bit more and figure out some other things to say. And this is gonna go with you for as long as you're in your professional life. So part of what I do is research. And to be able to get money to do research, I have to write grant proposals, which look somewhat similar to this. And they always have an upper limit on pages. And it's never the problem of filling the pages. It's always like, what do I cut out of my proposal to meet the page limit? Because they will literally not accept a proposal that's longer than the page limit. All right, questions about our project here, or your project. Everybody knows what group they're in, right? We have all that. Have all the groups kind of started connecting? You know each other. You have your phone numbers, email addresses, other whatever smoke signal codes. I don't know, however you want to connect, right? Make sure that you all know how to connect to each other. In your teams, make sure to remember that you're now a team member, right? So if somebody sends something, make sure to respond in a reasonable time frame, right? Don't wait for a week to respond to messages, right? Do it as soon as you have time to do it. My personal kind of setup is that you should respond no less than 24 hours. Right, so if somebody sends you a message in email or whatever, you need to respond within, at the very least, 24 hours, right? That goes for, I think, anything that you do here at the university. Now, that doesn't mean you have to have a solution or have everything done in 24 hours, right? That could just be like, I received your message, I'm working on it, like, this is where I'm going with it. Just something so that the person doesn't just sit there and think like, well, are they still part of my team or have they abandoned us, right? Because that's also often the case. As you're working your groups, you might want to think about different roles within the group, right? There might be somebody who is kind of taking a lead in different directions, right? There might be somebody who's looking to make sure that all the pieces get put together correctly, right? That we have one continuous project towards the end, right? There might be somebody who's kind of making sure that deadlines are being kept, right? You should set yourself internal deadlines, right? Just because this is due on the 28th doesn't mean that there's no deadline for yourselves before that, right? You should have like, well, by the end of the week, we want to have this. By then we want to have that. Like, how do we get there? How do we plan it? Right? So it's all kinds of stuff that you could do. All right. I think I'm done filibustering here. So if there aren't any questions, then I would recommend that you guys get together for the rest of whatever, half hour or something that this class is scheduled for, and could be on Teams and Zoom, on WhatsApp, whatever, and try thinking about what it is that you're trying to solve, what the problem is that you're trying to do, right? So this could be something that you thought about for your journal, could be something completely different, but remember that it has to be something specific, right? Ending world hunger, as great as a plan that is, you will not find a solution to, right? Like solving like all of Costa Rica's water problems, right? You're not going to find a single solution to that. That doesn't mean you can't go in and say, we want to find a way to better store water from the rainy season to be used for irrigation in the dry season in Guanacaste or something, right? That would be something that's very, very narrowed down and very specific. So that's something that you could do. All right, with that, I will let you go. On Thursday, we will be working on like an in-class project. So we'll be doing that. Is there something due today? No, I don't think we have anything due today. No, that's good. We have on Thursday, we have whatchamacallit, journal. Well, sitting on my words today, right? So remember that. And with that, I will see you guys on Thursday.
All right, thank you, Professor.
Yeah. See you guys
Thanks,
soon.
sir. See ya.
Thank you,
Bye.
Professor.
Hi, thank you, Professor.
Bye.
Thank you. Bye.
Bye.
Have a good one.
You too. Bye.
Thank you, teacher.
Right.
I have only one question.
Yes, go right ahead.
I don't have the
You don't have
I don't have the email or the number of my partners.
okay. That we can probably solve. Let me go and see. Where are we? Let's grab last week's presentation real quick because I don't know at the top of my head who they are. Bibliography. There we go. There we go. So the people in your group, where are you? There we go. We have Ezekiel Buck, Casey Nunez, and Luciano Vincent would be the people in your group. So if you want to, I can just send the four of you guys an email, and then you'll have all the ways to connect. That sound like an approach?
Yeah.
All right, I will do that.
Thank you, teacher.
Yeah. Bye.
Have a nice day.
You too.
And I just had a quick question on the journal. Is it fine if I can't get a picture I took of myself of like what I observed, but I found one online and I just cited it?
Sure.
Okay.
As long as it kind of goes back to something that you actually observed.
Yeah.
Yeah. Excellent. What did you observe?
Thank you. Oh, I had gone to Los Sueños, and I had seen, I don't know how to say it. How do you call the fruit in English? But they're like I guess grapes that grow near the beach. And so they had they just grow in the sand. Like you can see the patch of grass before the beach, but they're not growing on that patch of grass. They're growing like right in the sand. And they're always there. They were in season. And so I was like surprised at like how they could grow like just in the sand.
Oh, well, that's cool.
I think they're called uvas de mar. I don't know how to like sea
would make-
grapes.
would make sense. Yeah.
Yeah, yeah.
I
Yeah.
was thinking this the other day when I was looking through you guys' journals. It's like the amount of like nature that's available, like and exciting nature that's available to you guys is just amazing.
Yeah, it is.
It's like, oh yeah, I have sloths hanging out outside of my bedroom window. It's kind of like people go to
Yeah.
national parks to see these.
Yeah, I mean, I had seen a how do you say guacamaya outside my window this morning.
Yeah. There you go.
Yeah,
Oh.
yeah. It was pretty.
All right, yeah, it's totally fine to like, if you have that observation, but you can obviously it's hard to take pictures of grapes that are underground. I
Mhm.
can see that. Yes.
Okay. Well, thank
Okay,
you.
very good.
Mm.